Hello everyone, my name is Erol Kanay, and together with my teammates Utku Ala and Ömer Seyfettin Yıldız, we will present our study on page replacement algorithms. In this presentation, we will explore how the operating system manage memory when physical RAM is not sufficient. Virtual memory allows the program to run smoothly even when the available memory is limited. However, when the memory becomes full, the operating system must decide which page to remove. This destination directly affects system performance, response time, and total number of page faults. In our work, we evaluate the four major page replacement algorithms: FIFO, LRU, clock, and optimal algorithm. Our goal is to compare their behaviors, highlight their strategy and weakness, and analyze how to each one performance under same reference string. Before comparing the algorithm system, it is important to understand what a page fault is. A page fault occurs when a processor requires a page of the currently stored physical memory. When this happens, the operating system must bring the page from secondary store, which is slow and costly. Because of that, recurrent page faults is one of the most important goals in memory management. A good replacement algorithm minimizes the page faults and significantly improve overall system performance. Now let's move on to algorithm. Each page replacement algorithm follows a different strategy when deciding which to remove memory. Some focus on sibling, such as FIFO. Others aim for better accuracy by using access history like LRU. Clock provides the practical approximation of LRU with lower hardware overheat. And finally, the optimal algorithm gives the best theoretical result because it uses exact feature. Notable even to it cannot be implemented in real systems. By applying of these algorithms to same reference string, we can clearly observe of how their strategies affect the total number of page faults.
Hello everyone, my name is Utku Ala and I'm going to talk about the algorithms part in this presentation. In this section, we will briefly cover the basic concept of these algorithms without going into too much detail. Now let's dive into the specific algorithms. Our first algorithm is FIFO. It means first in, first out. As you can see in the photo, it maintains a queue. The new page is inserted at the head and the oldest page at the tail is evicted. FIFO is truly the most fundamental and simplest approach to page replacement. However, uh, despite being hardware friendly, it suffers from a significant issue known as Beladi's anomaly. So, what is Beladi's anomaly? Logically, you would think that adding more memory would reduce errors. However, with FIFO, increasing the number of frames can sometimes increase the page fault rate. This phenomenon demonstrates that more memory doesn't always lead to better performance. And here is our simulation of FIFO. Uh, As you can see in the tables, we tested all algorithms using a specific reference string with both 3 and 4 page frames. In this specific sequence, FIFO performed unexpectedly poorly because increasing frames doesn't reliably reduce faults. It is generally considered unreliable for performance-critical systems. Next, we have the LRU. It means least recently used algorithm. LRU replaces the page that has not been used for the longest time. It operates on the principle of temporal locality, assuming that page used recently will be used again soon. It performs very close to the optimal algorithm, and unlike FIFO, it avoids Palladi's anomaly. Looking at the simulation results, because LRU follows temporal locality, it achieves page fault numbers that are very close to the optimal algorithm in most cases. Our third algorithm is clock. While LRU is great, it can be expensive to implement. So, clock approximates LRU with much less overheat. Pages are arranged in circular list. The algorithm uses a clock hand to sweep those pages. It checks a reference bit. If the bit is 1, the page gets a second chance and stays. If it is 0, it is replaced. This gives us near LRU performance with constant time operations. Here are the simulation results for clocks. It performs close to LRU, but requires significantly less overheat. Interestingly, in the specific test sequence, clock actually outperformed all other algorithms when 4 frames were used. And finally, we have the optimal algorithm. The logic here is perfect. It evicts the page that will not be used for the longest time in the future. While this guarantees the minimum possible number of page faults, it requires perfect knowledge of the future. Since this is impossible in real-time systems, we use optimal purely as a benchmark to measure the efficiency of other practical algorithms. As you can see in the simulation, optimal serves as our target benchmark. We evaluate all other algorithms based on how close they can get to these results.
My name is Ömer Seyfettin Yıldız. I'm going to talk about in our projects compression section and analyze and concluding sections. Now moving on the compression section. If we look at the chart, the result gives us a very clear picture. As expected, the optimal algorithm on the far right side on the chart result is the lowest number of page faults. However, look at the FIFO on the left side of the chart. It's clearly performs the worst case, showing the highest number of faults. The interesting part in the middle section, both LRU and clock algorithm performance very efficiently, staying quite close to optimal line. This showing us that in the real world scenarios, we can achieve near optimal performance without knowing the future. So, what are key observations for this test? First, FIFO is unpredictable. As we can see, it's too simple and can actually degrade performance when we add more frames, something known as bleed anomaly. On the other hand, LRU proves to be best practical solution for the most cases. But we must highlight to clock algorithm. It offers excellent balance between performance and complexity. In fact, our specific test sequence with 4 page frame, clock actually result in the lowest page faults among the real world algorithms. In conclusion, this study confirms that effective page replacement significantly impacts overall system performance. While FIFO is easy to implement, it is too error for modern system. Our data shows that if you want stability and efficiency, LRU and clock are the superior choice, as they successfully approach the performance of the optical algorithm. And here is the academic reference and study used for this presentation. Thank you for listening. Have a good day.